sorry. I see what you're saying now.
All right, let me double check just to see that it's working. Okay, yeah, it seems like it's appearing on everyone's screen. Perfect. All right, in that case, thank you everyone for joining in on the Innovative Data and Analytics Applications in Energy panel discussion today. So we'll start off with an introduction of all of our panelists. So can you guys tell us what you do at your company and kind of, yeah, give an interesting fact about yourself too. So shall we start with Lee?
Sure, yeah, so my name is Lee Grant. I'm the supervisor for strategic planning and business intelligence at BirchCliff Energy. So I've been with BirchCliff for just about 5 years. I kind of started in a development engineer role with kind of a focus on analytics, and over the course of those 5 years I was spending more and more time kind of dedicated to analytics and creating corporate level solutions. So about a year ago we kind of broke off a smaller team, centralized some of that effort. So there's a group of 5 of us and we focus on 2 main things. So it's kind of delivering corporate level planning, reporting, and analytics that's typically consumed by our technical teams and then also our executives. And then the second focus is more on the technical analytics side, and that's including high quality data resources for teams, digital automation, and analytics solutions. And we strive to do this in a robust and repeatable way and deployed at corporate level. Some of the common tools I guess we use for that, we use a lot of Spotfire. We've developed lots of R code and R-based workflows. We do a lot of data virtualization. And we also have a big Hyperion and S-based Cube infrastructure environment for our corporate planning.
Wonderful. Now I'll pass it off to Vikram.
Awesome. Hello, everyone. I'm Vikram Mukhi. I'm a business strategy senior manager at Accenture. We help a lot of energy clients in the analytics space. The kind of questions we typically help clients with is one, of course, there is a huge imperative around how is analytics going to change the way energy companies work. So we help them define what their journey could be into the future and how they should leverage analytics to the most. A big part of that comes with a good operating model or a robust operating model. How do you make sure that there is a good analytics COE, or how is analytics ingrained into your day-to-day working organization? Which is a second question we help organizations quite a bit. And then we also help organizations in kickstarting some of the analytics use case, especially the high priority ones, setting up the foundations, the infrastructure, so that we start building something small in small chunks like MVPs, and clients can actually build off from there and continue on their journeys for a longer time. Very happy and excited to be part of the panel.
Awesome. And last but not least, Robert.
My name's Rob. I'm a co-founder and the current CEO of WhiteWhale Analytics. We're a company that started in 2015, based out of Calgary. We have solutions that we deploy that are in the data analytics space, and we work in a number of different spaces, but energy being a big focus, and obviously with the regional strengths we have here. But we've developed algorithms. Well, something interesting about me, I'm a physicist. Only physicists find that interesting, so I guess that'd be the interesting thing. So
Perfect. So let's get started. The first question to ask is, what are some of the most common applications of data analytics within the oil and gas industry that you're kind of seeing today? So that can include, different applications of machine learning or just software visualization, all sorts of stuff. So I'll pass it off to Vikram first.
Of course, great question and a very broad one. I feel like analytics is one of those things that is applicable across multiple parts of energy industry. And there is almost no field that at least I've seen where you can't apply analytics to actually improve things. When I think about the most important ones, I would sort of relate it to the broader challenges that the energy industry is facing in general, right? And I would say there are three of them. One is there is, of course, a cost pressure given the low oil prices. And analytics can really help companies run in a more organized way, increase their operational efficiency, and all the good things. The second one is what we would see is a lot of range bound oil prices and a lot of fluctuations between a certain range. And what that means is you need to manage your business through those life cycles or those oil cycles much more frequently. You need to be able to adjust to different environments. And what analytics does is it increases the pace of decision making by making sure different functions are connected and organized. So again, a huge impetus on that broad agenda. And the third one is that really affects our industry is the decarbonization mandate that a lot of us have taken over, and we really want to drive that through over the next few years to have a more sustainable future. And again, lots of interesting applications in all these three dimensions in my experience. Happy to go in more detail, but would like to pass it off to others to get their thoughts as well.
Definitely. I really do like the point of using it to further inform your decisions. I think that is a really important aspect of the change into data analytics. So I'll pass the question off to Lee now.
Sure. Yeah, so I definitely agree with a lot of those comments. I think at BirchCliff, we've tried to adopt a pretty broad definition of what are analytics. There's kind of a conception that that means like AI or means machine learning, but I think it starts with really good data and having available data for doing those kind of exercises. So we kind of like to say it's everything from good data to if you're making cross plots, if you're doing like clustering or even all the way up to AI. So we try to be pretty holistic in how we define it. Some of the major things I see, I guess, and both kind of I see in industry and then also a focus at BirchCliff is the machine learning use case of predicting well performance. So using those predictions to influence your budget and your well design. So where are you going to drill your next wells? How are you going to complete them? Is that the optimal design for a given situation? I think that's kind of a big use case for two reasons. Well results can change really dynamically, and sometimes they do it very quickly over short kind of geographical distance. Sometimes they change unexpectedly, and there's just so many drivers incorporated into that use case. It's everything from subsurface variables to how you complete a well, how you produce it. So it's so multivariate that it's definitely a use case that can benefit from an application like machine learning. And then I guess like maybe kind of a simpler one is like I'm seeing a lot of applications for production optimization and automation. So one of the common ones is on artificial lift, for example. There's some cool applications where you can kind of bolt on a widget to a pump jack, for example, and it will kind of autonomously optimize flow. So those ones are really interesting because it's so tied to your bottom line. It's really easy to kind of say, we improved flow by this much and that affected our bottom line by this much. So those ones are really nice to quantify some of that value add.
Right. I really like the point of using like machine learning and stuff and how I guess the application of it can go more and more specific as you need it to, which is quite good. It's also a good segue to Robert here. So WhiteWhale does do AI. Well, it's in the name. So would you be able to talk a little bit more about how that is mainly in data analytics within the oil and gas industry?
Yeah, so I mean, just speaking from, the things that we often do is like when we meet with different companies in the energy sector is we always have to identify like what is the kind of the path of least resistance for us to build something that does, to what Lee said, kind of move the bottom line. And at the end of the day, so where we're finding traction right now is certainly in the conventional and unconventional gas. So that'd be in the SAGD part. That would be effectively in SAGD. You're putting steam in the ground to draw up oil. that steam costs energy, and you want to get the most bang for your buck, especially with carbon emissions, for the steam you produce to get the oil out of the ground. So SOR optimization, subcool attenuation, making sure that nothing breaks. There's a lot going on in the fracking space as well. So effectively, forecasting both, your gas rates, your condensates and things like that, so that you can really in real time know how to change things at the plant level so that you're producing the right amount of commodities. And machine learning really helps when things go into curtailment and there's regulations that are set. Like this is just in recent history. How far do you pull that lever? How far do you pull back, and on which well and by how much? That's a big one. Predictive maintenance is something that we've delved in. We've had success in. But the thing is about predictive maintenance is that when we, for engineers, when we think about legacy technology, legacy airplanes or aircraft or pumps, these things were not equipped with processors on them, or the kind of knowledge that we have of physics today, where we expect a smart machine to say, this is exactly what's wrong with me, and I can run diagnostics. Mm. So there is a big play right now in predictive maintenance, where you can look at just sort of data points that may not have the same kind of resolution as modern equipment will. But if you can train a machine to read between the lines and say, hey, the reason that the sensor is reading this way is because you need an oil change. That's something that's also going on right now. I would expect that is important for now, but I don't expect that to continue forever, just based on the complexity of how we engineer devices now. And then other places in mining, anything that has this, basically when we say, how do we spend less time, space, and energy to do the same thing? In mining, for example, in a process flow, you might want to spend less energy effectively getting the bitumen out of the diggers, out of what you're digging out of the ground. And outside of mining, there's things in polymer flood that also have been really effective in machine learning. Any example in the oil and gas space where effectively what you have to do is you are pulling 100 levers at the same time, pump speeds, when you're configuring, to Vikram's point, like what does the completion look like? How many ways can we do this? And the more levers you have to pull, that's a lot of responsibility for one engineer alone. And so what data analytics does really, really well and is basically tying all these things together and say, how do we look at a field level solution? And that's what we're finding, I'd say.
Right. So then that kind of runs quite nicely into our next question. So what are some of the biggest changes you see in the oil and gas industry with the advancement and adoption of data analytics? So that can be, operational changes, changes in kind of philosophy and decision making, all kinds of stuff. So let's pass it off to Lee again. You're on top, so on my screen. So
that's okay. Yeah, so I'm gonna kind of, I guess, break the changes into kind of one or two things. So I think some of the big changes would be on the people side and then on the data side. So kind of on the people side, I think that there'll be a big change in kind of like workforce skills and knowledge in the analytics space. So how I see it is like traditionally it's kind of been like, well, you're either like a petrotechnical person, so you're like an engineer or a geologist, or even like an accountant, or you're more of like a tech savvy person, so you're a coder, or you're maybe in like more of the IT stream. And there hasn't necessarily been a ton of overlap historically, but I really see those two fields and those two skill sets having to converge, where I certainly see it now as like our technical professionals are more self-serving. It's not like, oh, we need that done, so we need to engage IT, and then they'll take it away and fix it, and those kind of things. It's becoming a lot more dynamic, but I still think there's a lot that has to change and improve in that sense. And then the second one I said is data. So I think in the oil and gas industry, we really need to improve our data. So a lot of these algorithms we kind of hear about, it's like they seem like they can almost do like magic with what they can do, right? But I think in oil and gas, we struggle to get data quality that's good enough that we can kind of get these like, unicorn outcomes. So I think like normally our main focus was drilling wells, completing wells, producing wells. It wasn't about gathering data and delivering data back to the operator. That was always kind of a secondary focus. But I see that changing. Like certainly at BirchCliff, like we're demanding better data. We're trying to get it faster. So can we get it even near real time? But often there aren't even standards really for a vendor to follow. So it becomes a challenge just to compile all that data in a consistent way and have it available in a way that can be leveraged easily for analytics. So that's really like in part what my team's trying to do is have the data ready so that people can go right to the value add piece of the analytics puzzle, not spend countless hours cleaning just so they can start trying to add some value.
Right. Awesome. Would you like to build on that a little bit, Robert?
So yeah, one of the things that the changes that like we're seeing so far is effectively what I see in actually really changing right now. Like if I had to think about changes from the perspective of, let's say, a younger company and building things out where you're not as deeply as entrenched as some other companies, and there's not even a whole lot of them, but let's face it, if you're looking at entrenched AI companies or machine learning companies.
Sorry, is it only on my end or are you frozen?
Here, Rob.
I'm good. I can
Okay,
see him.
sorry, apologies then. Yeah, I can hear you. Keep going.
So the changes that we see, and maybe when I read the question initially, I sort of thought, what are the changes I see right now? Well, oil and gas isn't doing as strong as it is. It's picking up right now, and there's a lot of things going on right now. So when I think about how does this affect the ability to deploy novel data analytic solutions or something in the AI field, this is already kind of a novel solution, and not everybody. There's a lot of limiting beliefs. There's a lot of when you say, hey, just trust this black box and it's going to work, and no one's ever seen it before. And in fact, maybe there's been cases in the past where AI hasn't done as well as it could today. And so what can end up happening is that, it's a tough time in the economy. So when I think about the changes for data analytics right now is that it is tough to embed it because we're not at $100 a barrel of oil. And they're reasonably speaking, like there was more appetite to sort of explore solutions, and now it's got to be really proved. Like, you know what I mean? The R&D component to that, the ability to pilot things and to sort of break down the limiting beliefs that a company might have, and right now, that's getting tougher. And so when I think about it for selling into energy companies, I just sort of say like it's a bit harder now, but there's other things too that are difficult for these companies. And I think that we're all going to get through. In fact, I'm confident, I'm sure that we will get through this, But I think the reality is right now, unless you have a solution that is really transformative for an organization that has a clear bottom line and it's at an affordable cost, which is what things should be. But the reality is there's less room for exploration and to really kind of try things, especially if you're a machine learning vendor. And so that's what I've seen the recent changes, but I expect us to kind of do this and go back up, right? And it's just really a function of the appetite to sort of explore and pay for these kinds of pilots or solutions. So that's what I'm saying is the big thing right now is the demand's not essentially where it always has been.
Perfect. So Vikram?
We'll be echoing some of the things that both Lee and Rob were saying. I definitely agree with like how Rob is thinking about it, as sort of the costs have really become a huge sort of target for everyone in the oil and gas industry and energy industry. There is less appetite to try new things on the analytics front. That is one side of the story. And at the other end, I think folks are also realizing that in order to sort of thrive over the next 5 to 10 years, this is something that is going to be a key competitive advantage. I
Mhm.
think all oil and gas companies would believe that yes, analytics is going to be something that is going to transform the way they work. Uh, so the appetite is certainly for initiatives that have a proven value or a proven use case elsewhere, even in the industry or outside of the industry. The good thing in this scenario for analytics is, since oil and gas industry, I would say to start with, was uh, not the tip of the spear in analytics, there are lots of use cases that actually can come in and help us do this cost reduction or help us get through this phase. I think some of the ones that both Lee and Rob talked about were predictive maintenance. As in rotating equipment like compressors, pumps, it's everywhere. Almost every industrial facility has it. Uh, and a lot of these use cases have been successful in other industries like aircrafts, general industrial complexes. And if we can actually lift and shift some of these successes into the oil and gas industry, I think we can get some traction over the next few months.
I think
That is
so.
probably an overall dynamic that definitely I see. Sorry, Rob, you were saying something. Go for it.
Sorry, sorry, I was just agreeing out loud. I agree.
Okay,
Totally. I totally agree.
awesome. In terms of people, very good points by Lee around there is a shift in mindset, and I do think that like the oil and gas operations or the day-to-day managing has become really tough over the past few years with all the pressures. And the good thing is folks are looking out for help, and that help can come in the form of analytics. I think one of the examples that actually Rob was mentioning earlier was the SACD operations. There was a time when all you had to do as an operational manager or asset supervisor is produce as much steam, pump it everywhere, produce as much oil. But so their entire operations is based on that mindset. But now after curtailment, after prices, what you're seeing is one, you can't produce that amount of oil. Second, you want to target the most marginal barrels versus producing the most barrels because the cost has changed, the prices have changed. And that takes a whole different mindset into decision making that honestly we never had. And analytics can add visibility to do those decisions better or provide more visibility to the operational folks that they can make those decisions better. So some broad thoughts on the question.
Are there any follow-ups, comments?
Yeah, I think it's like in no way to say, like, I think in way everything I think is making the same. Analytics is the future. I mean, when we say analytics, we've been doing this since probably we learned how to, make fire, and we kind of got better at that. And then it's kind of gone a long way since then. So I don't think it's going to stop anytime soon, but it's about how do you pivot to a market and make something survive in a time where it's just kind of tougher. And so the objective and the goalpost is maybe changing, and it's not the same thing as before. All you can eat steam, and SOR. What is SOR? No, I'm not saying that that's the way it ever was. But the reality is that the way that we're bringing down costs now you're putting in CO2 tax, which is obviously, I'm not saying that's a bad thing. It's obviously there's a reason for it, but what does that do to say now for the same amount of production, the energy, if we're burning methane to make steam and to put it into the ground, that's a new variable in the equation, and as it should be. So the problem gets more complex because you have to sort of optimize across more layers than perhaps more steam is better and run the pump harder and then just replace the pump if it breaks. I haven't actually been like in safety quite long enough to really experience that era. And I'm obviously kind of characterizing it, but when WhiteWhale started, what companies were looking for in 2015 were like 1% mattered. 1% of production change actually really mattered because times were really tough and oil was kind of at quite a low, and we've seen that more recently now. And that's a good thing because when you think about that, it's just saying, like, now when 1% matters, 1% should matter, the amount of energy we put into it. And now the analytics is just getting a bit more in depth, I believe, and it's just getting a bit more. It has to consider more variables at the same time, and it's for the better. So I totally agree.
And just hearing Rob speak, I think another thing that comes to mind that has changed quite a bit is I like what analytics has done is there is a democratization of technology. As in
Yeah.
earlier, a lot of these technologies were owned by a few companies and a few oil field service players. And now we have a lot of innovative companies like WhiteWhale Analytics sort of coming in and providing these solutions and being successful at it, right? So it's no longer that the technology is driven by a few players that have a knowledge. It is actually the entire ecosystem. And companies who are actually doing it successfully, they realize that and they say, okay, do I really need internal R&D for this? Or can I actually use a commercial off the shelf solution from someone and just plug and play into it? Because that saves you time, that saves you all the effort that it takes to train a neural network, which can be super uh, a lot of hard work. And if someone has already done that, then why don't we just use it and plug and play? So very interesting dynamics in terms of new innovative companies popping and the responsibility for innovation actually shifting across the industry.
Yeah, I really do like that point about like commercialization of new technology. Do you reckon that is part of the big changes going in? So like these that like basically solutions that used to be more specific and more tailored are now able to be made like almost mass produced in a sense. Any
Uh,
comments?
Go
oh,
ahead.
well, technology is the kind of thing where we know how it accelerates. And so, like in all of its complexity, and this is including the engineering in energy companies and everything that they're doing, and including in the development space, in the web space, in every single space, it's becoming more and more complex, and it's difficult to sort of to be able to master too many things at the same time. And so this actually opens up opportunities because there is, if anyone if the person I know who underestimated the complexity of a software platform was me, because I'm a physicist and I said, well, how hard could it be? And it turns out that there's this niche that I don't even touch too much of it in terms of an actual platform development or software development, because I equate it to doing brain surgery on a rocket launch. Is kind of like what it's kind of feels like after 5 years of everyone kind of working together and seeing this code base that's 10,000 lines of code to one, for something that I would write as a data scientist. But this also extends to an energy company where the complexity of what they're doing and their understanding of the physics and of everything, their process, that's also been accelerated a lot. And so I do think that it's kind of like going from the broad niche, which is kind of like the Canadian wilderness where animals survive 4 seasons, and they're very to the jungle, where you have these niche things that are super adapted, and that's what really it's all about. And so it opens up space to say, like, if you want to, you can be really good at one thing. You don't have to master all the things. And I think that's what I think that's the kind of point Vikram and Lee are saying. So there is an opportunity, and when I say that it's a tough time in the energy space, that's just reality. But is there more opportunities as a result to specialize given the technology at hand? Absolutely. So in terms of commercialization, you just have to really hyper focus at the thing that you can do really, really well. Because technology is getting quite, like, the scope is increasing a lot right now and becoming very complicated. There's things that come out every single day, where if you're a technology or a software company and you aren't built in a modular way, where if you were built on something and it's basically the foundation of everything you've done, and then if something better comes up the next day, if you can't swap that out, you could be history. And so the tendency for a software company is to not do that. And so you're always looking at this, you're always modularizing, but it could be very hard for a large organization looking at across the entire scope of everything, including the technology, to really be able to do that. So there is an opportunity. You just have to, you just got to focus on it.
Right.
I'll throw in one more quick thing. Vikram, you kind of alluded to, like, taking off-the-shelf products that may be, very specialized and good at one thing, and kind of being able to deploy quickly versus internal development. And that just resonated because we often have that kind of debate internally, and we refer to it as build versus buy. And when does it make sense to do each of those things? And, we do, I'd say, a combination of the two, but it's a constant conversation on, if you're building internally, but then somebody comes along with a really good off-the-shelf option, like how much thought and time do you put into that, or do you continue down your own path? So, we're constantly approached by people. We constantly have to assess what's out there and take on pilot projects or work with kind of partner companies off and on. It's kind of, we have multiple things on the go at all times, it seems.
Right.
Yeah. If I could add one thing that and that really is been our experience. And so to be reactive, because the thing about just being a kind of machine learning, kind of pure platform company, is you are not the subject matter expert with it. Like every single interaction you have, every opportunity, right? Like the expertise, the knowledge always comes from the client or partner. And what I would say to be successful in data analytics is to kind of not lose sight of that. And that it's better to listen than to know. But if you can and say, well, there's this solution that we think is going to work, and just getting the opportunity to at least try that, that's the win. Because I totally agree. And I just think that that's what I was really talking about, niches there, right? You got to find it there and then deploy the solution, but you got to listen the entire time.
Find the niche in a sense. Awesome. So I'm going to shift gears a little bit here. So the next question is, what are, also a lot of people these days are trying to gain data and analytics skills to be more competitive in market, because it is something that, I think all employers are looking for currently. So how do you suggest students without a data science / software background kind of make themselves more competitive? So how do they learn? What do they need to learn to really be competitive in this new field and to really be able to, be competitive within the market? So I'll pass it off to Vikram first.
Sure. So that's an interesting question. The two things that come to mind are, one of the analytic skill sets that I think is very underappreciated is just the ability to structure a problem and say that, okay, if this is the business problem, what exactly is it and how would analytics help it? It doesn't mean that you really need to understand all the things like a neural network and a k-means clustering and so on in detail. You just need to understand what these methods are and how they can be applied to solve a problem. I think bridging that gap is the first thing, and not a very hard skill set to, I would say, build in terms of knowledge. It's probably something that comes with practice. And if you practice that more and more, read about solutions more and more, you will find that a lot. The second thing I would say is with time, the data science tools have actually become simpler than more complex in terms of learning them. There are tons of Coursera courses available. Like there are some very good from Stanford, some very good from like a few universities, and you can learn these skills very easily. So if you are really interested in this field, learn programming. There's nothing stopping you from like taking a Coursera course on a few weekends and just build something. The third thing I would say is like jump straight into it. If you find a problem either in your class or in a project or on an internship that folks have been doing in a certain way and that requires a lot of manual steps, and you can see that analytics can solve it, go in and build that solution for them. It just with a little bit of hard work, you can actually build a solution. This is one of those things that doesn't require you to always pull like 1,000 different people in a room and run a massive project. You can actually get impact even by one or two folks working on something for a couple of weeks. So do that, and that's great experience, and you learn by doing. Those would be my three big advices for someone who's looking to get into it.
Right, right. So now I'll pass it off to Lee. A lot of my friends in like ChemEng and everything and MechEng have been going into a master's to do computer science as well. So it is something that we see like happening quite a lot within the energy sector, especially for new grads. Could you speak a little bit more about that?
Yeah, sure. Yeah, I guess like I have, it's interesting because I maybe did the pivot from more of a kind of traditional technical role, and I was an engineer, and I started off very much doing the standard kind of stream where I did completions and facilities and production engineering, all those kind of things. And I was able to somewhat pivot, but I kind of did it maybe a little bit by accident. But yeah, I definitely agree with a lot of things Vikram said. Like, there's tons of training out there. There's a lot of resources. It's a really good situation because, to learn a lot of like the technical energy skills, it was usually pretty specialized, and you'd have to take like a $5,000 5-day course, whereas you can learn programming for free on the internet. But also what Vic said is like, you got to commit to learning it. So you got to be thinking every situation, how could I employ it? How could I improve that workflow? And really just like take that on. And I think that's something I definitely tried to do. So I would try to identify things that could be improved with code, even if, my boss didn't know it was possible at the time. And he wasn't like, hey, Lee, you need to code this into a better method. So just try to be imaginative and innovative, and have that lens when you take on problems that, how could this be better or more efficient with either code or analytics or machine learning.
And finally, Rob.
Well, yeah, yeah, all those skills. And like the reality is there does have to be, you have to learn how to code a little bit. And it's not to code in a certain language. We got to learn how to think like a coder. I know, and this is what I think we've been saying, is to think like a coder. It doesn't matter if it's MATLAB or Mathematica or R or Python or Java. You need to put in some hours there to at least say, okay, I'm comfortable with coding. When I look at this, it doesn't look like the Matrix, and it just freaks me out. It has to at least have that part. If we were to, to really draw a line, you have to be able to code a little bit. But once you just kind of get a little bit comfortable with coding, then you can start progressing a little bit. So it has to be a coding component. And, I completely agree with what's been said. And outside of that, so I won't repeat it. Outside of that though, what I would say is like, I have never known anybody who was really passionate about something, and they, and dedicated to it, and they weren't any good at it. And so I know it's kind of like the, maybe the cliche, but at the end of the day, like if it's something that you're passionate about and you're going to push and keep doing, like if it's the right thing, that's what it requires, because you can't get good at something if you don't like it, or if you're not interested in it. You're forcing yourself to learn it because it's out of necessity. And you think, because I get this, I got to learn data analytics, even though I really don't like it. I'm not even interested about it. And, but I just need it for a resume, or I need to get a job. That probably won't set somebody up for success. And so the thing I think about here is there's a quote from somebody that I was watching an interview. And basically they said, the story is that when this person was young, their dad wanted to be a musician. And instead of going down the path of being a musician, they went to work at a factory. His dad went to work at a factory because it was the safer play. It turns out the factory went bankrupt. His dad lost his job, and they were homeless for a little while. And he said it occurred to him that don't just you can still fail, or you can still not succeed doing what you don't love. So you may as well risk failure doing what you do love. And so, where he went on from that was, he's like, I like being a comedian. And this guy's name is Jim Carrey. So he was successful as a comedian after the fact. And so I think that's a very important point, where it's like, you got to still do what you love. And I think that has to be there to make the magic of success happen. So.
Right. Awesome.
One,
Yeah. Oh,
one thing
go
I
on.
would like to stress is that I think with things changing so quickly in the analytics space, it is one of those spaces where you cannot afford to be, I will learn until I'm a student and then I'll apply it. It is something that you just have to learn on a constant basis. You are a student for life because technology will change much quicker and those changes will actually be faster in the future. So make learning integral part of not just your student life but also your working life. I learned to code probably 3 years back, very well into a career, and it is, and I think some of, like, if on the outside things do look like matrix, like Rob was saying, like things are like, oh my god, what is like written there, but they are not that tough if you just put in a few hours or a few weekends on it. So make that effort, learn things, you will see that they are worthwhile, and you will be able to understand everyone much better. Like if you're a business person, you'll be able to understand data scientists much better, and vice versa. If you're a data scientist, you'll be able to understand the business aspects of things much better. So make that a part of your life.
Hmm. Any more follow-ups, Lee?
No, I agree with a lot of those comments. It definitely resonated. I'll hold off. We can leave some time for questions.
Sure, sure. So yeah, as we go into questions now, I'm just opening up the questions. So I think the first one is probably for Rob. So do you think AI can be used to optimize the whole general process, not only production, but up to the delivery and final use? So such as how much extra carbon there would be just from transport and method of usage by the consumer?
It can't do it alone. It can certainly, wherever there's data, wherever there's data, we must consider like the AI being something with this eidetic, almost omnipresent knowledge at all times, because it's reading all the data from all the different places at all times. And there's always action at that time with the right trained model that you can make a good decision. But can it optimize? Is it going to invent, the next clean energy? It probably not on its own. It has a place to live. It can certainly help. I believe in all the things that you just listed. It absolutely can help. I can name cases where it can help in all those different things. But to make a solution really transformative, I don't think we can just necessarily leave it to the machine learning or data analytics to say, like, how do we think outside of this thing, which is already in a box, in a way, right? And so when it comes to innovation and engineering, yeah, no, like it's certainly not like AI. The way I always think of it is like computers are really, really good at some things, but I just don't. They're not as smart as people. They're just not. And the way I kind of think of that is like, not to go into too much detail, but it's just kind of like when you think about engineering, you kind of think about, okay, when you solve a problem and you write down every step in your math problem, it's kind of codifying what your brain was going through. Okay, first I thought this, then I thought this, and I thought that. This is the kind of stuff that we can lend to a computer, or we can encode to a computer. So what were we thinking? We can dive deep into that. But when you ask an artist or you ask a music like Beethoven, you said, what was your process when you thought of this music? That stuff's a lot harder to encode to a machine. And so we won't always have both aspects. And so the computer is really good at taking the pieces that are, we have, I almost call it a read, like access or read access in our brain to say, what are we actually thinking? The steps that we can read, then the computer can really help. But there's a whole lot outside of that, and creativity, and just when I'm thinking about engineers and all the solutions that came out that were not a result to date, before even AI was around, all the things we had before didn't come as a result. So I think that it can always help in those cases, but it will in no way do it by itself, or do everything by itself. So it can certainly help though.
Awesome. So this next question is, I think, for everyone. So for people with an oil and gas background, how do we go about getting relevant data analytics and AI trainings that employers are looking for? I'll combine it with another question too, which asks, what are the relevant programs that are used currently within industry too?
Sure, I'll try to jump in, I guess. Yeah, it's kind of a tough question. You know, it's like, how do you kind of stand out on a resume, so to speak, if maybe you haven't had that opportunity to have like a formal analytics role or something like that. So, you know, in some cases, people might have, they did some really great experience in like a production engineering role, but their, you know, their job description wasn't formally analytics. So I guess what can you do? And it's tough, and I don't know if I have the best answer, but you know, there's a lot of momentum happening on like different hackathons within the city and stuff like that. So trying to focus on oil and gas data sets to at least get some experience kind of applying it to that domain, because you know, you can do examples online of all kinds of things with test data set, and it's useful and it's great to learn the fundamentals, but to actually apply it to industry is, I think, like how you can try to differentiate yourself.
Awesome. Vikram, Robert, would you like to jump in as well?
Probably echoing some of the things.
I should have. Sorry. Oh, sorry.
Go ahead,
sorry,
Rob. I was going to say that I think a lot of times we do get hung up on which language or where do we start.
Okay.
And there are like multiple places to start with. What I would say is like pick one. I think there are a few languages that are super famous and you can pick one of them very quickly. What is important though is, and what differentiates, I would say, good candidates from great candidates when you're looking to hire for an analytics role is it's not so much the technical knowledge or the depth of it, because that comes with time and that varies by problem. It is the attitude and the mindset to actually use that and having solved a problem. So if you have, for instance, participated in a few hackathons, that is much more valuable than like 50 hours of training on a certain language. Or if you have actually used something even simple to solve a real production engineering problem or a reservoir engineering problem, that to me is much more valuable, because that shows that one, that you are interested, you want to apply it, and a lot of learning happens as you are applying it, because you will run into a problem, you will say, okay, how do I solve this problem? Is it a linear programming problem? How do I solve it? And then you take it from there, versus trying to sort of learn everything that is data science, which I don't think anyone can ever learn, and going from there. So I would take that route much more, and that will make you stand out much more than trying to learn a lot of things and then saying, okay, now let me apply it.
Yeah.
Awesome. So next question, that's also directed to Rob. What are some of the KPIs through which you measure success of achieving business objectives? So what are some of the barriers today to meeting your proposed targets, for example?
Oh man, that's that's a really hard question. I don't know. No, I think that okay. It depends what kind of lens we look from. So we're looking from a company, a growing company, sustainability. How do we remain relevant? And then it's kind of this fine balance of being diverse. So then sustainability, what does that mean? It means diversity. It means make sure that even though if we have one really, really great widget and it works really well for one thing, if that thing were to evaporate, where are we? And so I think that looking at things and basically looking at the broad pieces, maybe rather than, so how do I measure it? I guess I would say, okay, culture, team culture. If we're going to talk about companies, it's about who are the people or you surround yourself, who are your team. That's probably the most important thing at the end of the day, because no one person is greater than the team. And so that's why I need the team here to answer this question. Because really at the end of the day, like what we do is we like to say, okay, you can set, I don't believe like stretch goals, but what you have to do is you can't stretch yourself in 100 different directions and say that I have this AI that we're going to go, that's going to solve everything, because that puts the product team down the wrong path. When it comes to the operational team, you can't say, okay, we're going to go, have a solution in 50 different sectors. And, and it's all going to have bells and whistles on each one of these things, because that doesn't work either, because you don't develop, at least the subject matter knowledge to even be able to, for that to actually lead to success. The way that I would say that we measure it, that we're doing what we're right, is that are we staying in our own lane? And if we are the most critical of what we're doing, and the way we validate it, and we say, are we being mathematically objective here? Are we happy with this solution? Does it matter what the guy across the street is doing? Does it matter what we read in the news about what else is going on? Those things I can tell you for sure can't steer it. You can't like, it's good to know, but like to really build something and take ownership of it, you have to be the biggest critic of yourself. And you have to, if you're the most critical of a solution and all the things that can go wrong with it, when you put it in front of a client and you are the most critical, they're not going to ask you anything that you haven't thought of. And you're going to have thought about all the things that it could go wrong. What you can't sell is crap, right? Where there's a lot of smart people in every single room, and they're going to look at it and say, yeah, this, I'm not sold. This doesn't work. And so I'd say that the way that we measure it is like, are we happy with it first? And if we are the most critical of it, do we buy into it? Would we buy it? I think that's kind of like almost the golden rule at the end of the day. And do we believe in the value behind it? Because if you have a lot, because if you do, then you can take a whole lot of that conviction and that belief, and then take that. And I think that's the number one rule: is you can't really fool yourself with what you're doing, right? So I don't know. I know I said like 100 things there. Probably none of them made sense, right? Maybe half sense, and then you add them all together, they made 75% sense. But it is a really tough question. How do you measure success? Like, it's like, how do you measure, you know, like health on a company and things like that? It's I'd say when you set a goal and you set when you set a goal, like, just you really like buckle down with the team, and the only way you're going to get there is when they're all aligned. And if you do that, you'll succeed. But you got to be the most honest and critical about it. So.
Right. And I think this will be the last question before closing remarks, and it's directed at Vikram. So what specific problem are you solving with neural network in oil and gas? And what advantages do you get from using neural networks that you don't get from other models?
So one of the problems that we are solving is, so let's say there is a SAGD operation where you are actually pumping in steam and getting oil output. The biggest question is, in which wells do you pump the steam, and how much steam do you pump in to get the most oil output currently and into the future? Now, if you look at it in a very traditional way, this is a very reservoir engineering problem where you look at what is my reservoir model and how do things sort of interact each other inside the reservoir. And what we are trying to do is supplement that reservoir engineering with a machine learning lens to say that, okay, let's look at the last 5 years of all the sort of steam injection patterns and the oil output patterns. And from that neural network training, can we predict that if we were to actually inject this amount of steam there, then this is the oil output that we get. So that is the core model. And then from that, you can actually optimize it to say that, okay, if this is how my predictive model works, then what is the optimized output of that predictive model? That's one of the problems that we are solving through neural networks. One thing I would like to say is that a lot of times technologies such as neural networks are not the most influential or effective ones. Like on the same project, we are using things like linear programming and very sort of things that have existed for the last 50, 60 years, nothing new about them. And we are solving some of the problems that are being much more, getting much more traction than the neural network problem. For example, I think one of the earlier question was around being able to optimize carbon and your carbon emissions in a SAGD operations. Now, one of the key challenges that companies really face is they look at carbon emissions as an afterthought. So they would do the full year, they would conduct an audit, say how much the emissions were, this is my threshold, this is above threshold, and this is my cost. It is not like the cost of carbon is ingrained into each and every decision that is made. So if I decide to produce 5,000 more barrels of oil from this field, how much is the carbon impact of that is going to be? And that's a very interesting problem that did not really involve a neural network. It's a problem that involved understanding the carbon emissions, programming it, and just giving an output to the field engineers. But in terms of impact, I would say it actually got more impact than the neural network one. Just a thought. I think sometimes like big terms like neural networks and machine learning does carry us. A lot of times they are immensely powerful, but a lot of times the traditional technologies are actually equally powerful and useful. So don't underestimate them.
Yeah, I have to add one thing to that too, because especially on a neural network, I'll just, it's a fact to date with every solution WhiteWhale's deployed, and we don't do computer vision, we don't do some things that neural networks are especially good at, but I'll tell you to date, WhiteWhale, we only able to deploy one neural network, and it was something similar to what Vikram said. So neural network is a fascinating topic. It's really important to know. But I think if I'm right, Vikram, what you're saying is like it is something that is basically like a bedrock of how we can think of these problems. But I'm still amazed of how many more regressions we would use, or a decision tree. Like we use this everywhere. A stats model, Bayesian model, right? These things show up time and time again. So the neural network, like definitely learn it. But it's always surprising to see to me that it just hasn't shown up nearly as much as the most optimal solution. So I would explore decision trees and things like that.
Yeah,
Absolutely.
I think there's like this tendency to people seem to latch on to like one specific model type, and I've probably done it myself in the past where I've gone like down the random forest rabbit hole and learned a whole bunch about it and got really excited about it. But I think what's more powerful to do is have a broader conceptual understanding of many types, and then be able to apply, for example, many types of models on the same problem, and then have the understanding and the ability to evaluate all of the results and actually determine which is the best for a given problem. Because there's no kind of one model fits all situation. And yeah, sometimes like you might be able to get, say, an R squared or error value that's comparable with like a far simpler technique that you could bring back to a technical team and communicate far easier. And I think you're just going to be more successful with that solution because you can actually describe and communicate how the levers are being pulled, I guess. And I think the team has more comfort on it in that sense.
Awesome. On that note, if you guys have any last closing remarks, and please say them, and then we'll have to close at that point. So, Rob, closing remarks?
Closing remarks. How's this? If anybody if there are additional questions or anything like that, you can always WhiteWhale, you can just reach out to us, and we're happy to follow up on it. So if we don't contain it in this space today, that's just whitewhale.ai. So please feel free to reach out to us.
I think all of your contact information is both in your speaker bio as well as in the sponsor bios as well. So it is there for any people that want to reach out. Vikram?
Awesome. Yeah, it was great discussion, and thank you for having us on the panel, and looking forward to being in touch with everyone, including some of the audience. Feel free to reach out. Happy to engage on this topic. Super interesting, and yeah, very looking forward to engaging with everyone.
Awesome. And last but not least?
Yeah, I'll keep it brief. Thanks a lot for having me on the panel today. Hopefully people out there got something out of it, and are able to take something away as you kind of go down the analytics journey, if that's where you're headed. Yeah, I guess if you have any questions.
Awesome. In that case, thank you guys so much for joining me, and I will close the live stream now.